going to explain module 1 basic concepts in the network analysis. So in this we can expect sometimes they'll ask some definition for some terms. So let us discuss some of the definitions. So the first topic is independent sources. Independent sources in an independent sources, the voltage is completely independent of current, or the current is completely independent of voltage. So independent, the meaning, the word itself indicates that it is a independent, it is not depends on any other things. So if it is a voltage source, voltage does not depends on current, and if it is a current source, current does not depends on voltage. So let us consider independent voltage sources. In the independent voltage sources is also called as ideal voltage sources. The symbol for that one is within a circle, plus minus. Plus is the positive terminal, this is negative terminal. Sometimes they may also give current direction here outside, not inside this, and sometimes they also give plus minus. If a current is going upwards, they will give like this. And how to write if you connect any load for independent voltage source. If I connect, see, this voltage source does not have any internal resistance, only voltage source is there, ideal voltage source, no resistance. Okay, and if I connect a load, voltage across this load will be always equal to this supply voltage only. So if I take a graph of VL versus IL, okay, voltage remains constant. Okay, voltage does not depends on IL, so always voltage will be constant. So that is the case in case of independent voltage sources. Consider practical voltage sources. So in ideal voltage sources there is no series resistance. Now consider a practical voltage source where we have internal resistance of the source. So this is represented by an voltage source of magnitude E or V in series with internal resistance or impedance. If it is a DC network, we call it as a resistance. If it is a AC circuit, we call it as a impedance. Now, if I connect same like here I've connected RL, no? Same if I connect RL and if I measure the voltage, the supply voltage, okay, this E is not equal to VL because some drop will appear across this R series internal resistance, no? Some voltage will be absorbed by this resistance. Okay, so VL is not exactly equal to this, so there will be a little bit less here. Okay, so it is a graph of again IL versus VS. Ideal representation is ideal source means you will get like this because there is no series internal resistance, no voltage drop here. So whatever supply voltage you give will appear across load. But in case of practical sources, we have internal resistance. So this there will be a little bit drop here. So if I increase the voltage and VL is not following this much because some drop will be here. If I increase the voltage, current also increases and drop across RSC also increases. SC means series internal resistance. So this is the ideal one, but practically VS is going to reduce as you increase the IL. The value of this voltage will be going to reduce. That is because of this drop IL into RSC. As IL increases, this drop is also increases. Okay, so this is IL. As IL increases, this drop also increases. So your VL is actually not constant, it is actually decreasing. So in the ideal sources, okay, RSC will be zero internal resistance. So this is short circuit means zero resistance. Okay, practically it will have some resistance. Next, independent current source. How to represent independent current source or ideal current source is circle. Inside the circle arrow mark should be there. Inside the circle, no plus and minus, arrow mark should be there. Arrow marks indicates the direction of the current, whether it is going upwards or downwards. This is a symbol of independent current source. And if I connect any load here, if I connect any load here RL, in series current remains same. In series current remains same. So the value of current is always equal to the current source value IS. See, irrespective of VL, IL is constant. Load current is constant, which is same as source current. Okay, it does not depends on VL. So this is a case of ideal current source, and it does not have any resistance parallel to it. Okay, in series current remains same. Here there is no resistance. Resistance means it is infinite. There is no parallel resistance across this, so you can consider as infinite resistance. So definition for independent current source is it is a source which gives constant current at its terminals, no terminals, irrespective of voltage appearing across its terminal. Consider practical current sources. In the practical current sources, there is a shunt resistance. RSH means shunt resistance, or you can simply write RP or RS or anything, source resistance. It is represented by a source of strength, current value, high value in parallel with its internal resistance. Remember, in voltage sources, we have series resistance. Always for a voltage source, you have to connect series resistance. For a current source, you have to connect parallel resistance. Okay, in case of DC network, we call it as a resistance. In case of AC network, we call it as a impedance. Now, for this practical current source, where it has internal resistance, which is connected parallel always. If I connect a load here, if I connect a load here, so in case of independent, there is no parallel resistance. So in series, current remains same. In this branch, current remains same. So IL is equal to IS. But here we have internal resistance path and load path. So definitely current division will takes place. Some part of the current will flow through this internal resistance path and remaining current will flow through IL. So that's why as you increase the voltage value, like in ideal current sources, we are getting constant line now. That type you are not going to get. It will be little bit less than IS. It is little bit less than IS. Source current value is IS. It is less. IL will be less than that source current value because some current will flow through RS shunt resistance. Okay. So if you can apply KCL here, IS is equal to ISH plus IL. IL is equal to source current minus shunt current. As you increase the voltage, okay, the shunt current also increases and IL is going to decreases. And for ideal current sources, shunt resistance is parallel resistance is infinite. Infinite means open circuit. So here you can assume that infinite resistance is there. That means infinite means open circuit. For voltage sources, internal resistance is zero means short circuit. Straight line means zero means short circuit. Here it is open. Across parallel we have open. Between here to here it is open. Always for practical current sources, shunt resistance will be there. If you don't write anything, that is nothing but it is infinite. For ideal, it is infinite. Yes, for ideal current source, it is infinite. Next important term is what is independent source? We just know. No? Now let's consider about dependent source. Dependent source is also referred as control sources. Its value is controlled by something else. Okay. So now let's take four different control sources. Sources in which either the source voltage or current depends upon current or voltage elsewhere in the circuit. So in the circuit only, it depends on some branch voltages or some branch current. So based on that, there are four classification: current controlled current source. So how to identify dependent source? How to identify dependent control source is, so for ideal, we have circle shape. Here we have diamond shape. So this is a diamond shape. Here its value is, arrow mark is indicates that it is a current source. Diamond means dependent source. Arrow mark means it is dependent current source, and its value is k times Ix. Its value depends on Ix. So it is this current value controlled by Ix, where Ix is in the circuit only. You have to find where Ix is given. So its value is controlled by the circuit branch element current Ix. Okay. So the magnitude of current depends upon the current flowing through some other part of the circuit, where they will mark Ix in in the circuit. In some branch current, they will mark it as Ix. So depending on that, its dependent current source also going to vary. Similarly, this is also dependent source. It is also dependent source, but its value is controlled by Vx. So where Vx is voltage across some element in the circuit. Okay, so it is voltage controlled current source. It is a dependent source. Diamond shape is there. Arrow mark means current source whose value is controlled by Vx. It is a voltage controlled, okay, current source. Similarly, you can also have voltage source. First, it is a dependent source. Dependent source means diamond symbol. Current source means arrow mark will be there. If it is a voltage source, plus minus will be there. Again, now it is a voltage source, dependent voltage source whose value is controlled by Vx. So it is controlled by voltage. So voltage controlled voltage source. Voltage controlled voltage source. Similarly, last one is it is a dependent source because diamond shape is there. Plus minus means it is a voltage source whose value is controlled by Ix. So it is current controlled. It is controlled by current controlled voltage source. So next we have important definitions. What is the difference between circuits and network? Okay, interconnection of two or more simple circuit elements like RL, okay, resistors, voltage, null, no? So if you consists of interconnection of two or more simple circuit elements is an electrical network. If the network contains at least one closed path, okay, at least one closed path, it is circuit. Circuit means it should be closed circuit. Network means without closed circuit also, simply joining of two three circuit elements. Okay, connection just connect two resistors. That is also becomes network. But circuit means it should have at least one closed path should be there. Okay, every circuit is a network, but not all the networks are circuits. So next, network analysis is a subject name. It is a process of finding. It is a process of finding by applying. It's a process of finding circuit elements like current or voltage by applying techniques. Analysis of circuit involves calculation of current to an element or voltage across the element. You can find out parameters like current and voltage by applying some techniques. That is actually network analysis. So there are various techniques available. Ohm's law we have to apply. Then Kirchhoff voltage law, Kirchhoff current law, mesh analysis, node analysis, then network theorems. Using all these techniques, we can find circuit current and voltages. And we also use some transformation techniques like source transformation technique, source shifting, star to delta, delta to star conversion, etc. And sometimes they will ask you define following terms. Okay, so they will ask you what do you mean by active elements? What do you mean by passive elements? Electrical elements are broadly classified into active elements and passive. You have to write active element means which can generate energy are called active elements. Examples are voltage source and current source. In your circuit, it should contain voltage source or current source. Then we call it as active elements. These voltage source and current source are called as active elements present in the circuit. What are the passive elements in the circuits are elements which cannot generate energy but can dissipate energy or stored energy in the form of electric field or magnetic field are passive elements. Examples are resistor, inductors and capacitors are called as passive elements. Voltage source and current source are called active elements. Passive elements are resistor, inductor and capacitor. So resistor does not generate energy by itself. If you have any active elements, then current will be there and it dissipates energy in the form of heat. If any current is passing through the resistor, you can feel the heat. Okay, so it dissipates energy in the form of heat in case of resistor. In inductor, it stores energy in the form of magnetic field, and in capacitor, if current flows, okay, stores energy in the form of electric field. So capacitor is going to get charges. In the inductor, magnetic field is going to store in the form of magnetic field. In the resistor, energy is dissipates energy in the form of heat. So this is the important question. what is active elements, what are passive elements. You have to give examples. Voltage source and current source are active. Passive elements are RLC. Next, they may ask you, what do you mean by linear and non-linear elements or non-linear networks? A network is said to be linear if the principle of superposition is satisfied. Simple principle of superposition means here only one voltage source is there, response is R of t. E is excitation, this is response. And the second excitation is E2 R2. For E1, the R1 is a response. For E2, R2 is a response. If I give both, it will be net of those two. So response of first one plus response of two. So it is linearly increasing. Similarly, if I increase one more voltage here, E3 of t, it will be equal to R1 of t plus R2 of t, R3 of t. So output is linearly varying. Okay. If I give more number of inputs, output is also increasing linearly. That is linear. If the condition of superposition is not satisfied, then the network is called non-linear. Okay. Next, what do you mean by active and passive network? So you can see in the passive network, I told no passive elements are RLC without any voltage source. Active elements without any active elements, if you it consists of only resistors, then this is called as passive network. A network which does not contain any active element like voltage source and current source are not there in the circuit. That's why it's called as passive network. Active network means a network which contains at least one active element. Here it is one active element is there. Actually in this circuit two active elements are there. Even without this current source, then also it is active because voltage source is active. Even current source is also active element. So at least one active element is there. Then that network is called as active network. Next definition, they may ask you, what do you mean by unilateral and bilateral? Because in the definitions of theorems, we are going to write in a linear bilateral network. So what is the meaning of bilateral? A circuit in which voltage current remains unaltered with a reversal of polarity. The source is said to be bilateral. Suppose this is a circuit, okay, and some current is flowing through R2. If I reverse the battery, minus here, plus here, then current in the R2 becomes opposite of current. So for example, 2 amps is coming, then minus 2 will come. Then that is called as bilateral. A circuit for which current or voltage relationship remains unaltered. Okay, only the polarity will change. Plus current becomes minus or minus becomes plus. Its value is not going to order. Its magnitude will remain same. Only polarity is going to change. That is bilateral. In the unilateral, okay, with the reverse of polarity of the power supply, okay, the response, okay, the VA characteristics are different with the reverse of polarity. For example, if you have any diode here, which is a unidirectional device, okay, in the entire circuit, if any diode is there, if I reverse the battery, then diode is unidirectional, it will become reverse bias and current becomes zero. So that's why if the VA characteristics are different with reverse of the polarity of the sources, then that circuit is called as unilateral. Example means any semiconductor diode. Next is what is a lumped and distributed network. Elements of the circuit which are separated physically are lumped networks. Examples are L and C, inductor and capacitor. They are actually present in separate physically they are separated. We can take inductor connected, you can take capacitors, and it is we can identify as a capacitor as a inductor. That is actually lumped. Elements which are not separable are for analytical purpose. They are as distributed network. For example, you take power transmission lines. So they have RLC components, but they are not physically separated. They are distributed along through the transmission line. So that is called as distributed network. Lumped one is which are separated physically, and distributed are which cannot be separated for analytical purpose, but actually they are distributed throughout the lines. Next, last one is reciprocal network. A network is said to be reciprocal when the location of excitation response are interchanged. The relationship between them remains same. Okay, so that is reciprocal. It is said to be reciprocal. Excitation means voltage source, response means where the load current is coming. The ratio will remain same even though if we exchange response and excitation positions. So next we'll start with another technique, source transformation technique, in the next video.